Right. Right. Good morning, Daruni. Today we can start a new lesson, right? Take down the topic. Chemical kinetics. දැන් සියලු දෙනාම නිශ්ශබ්ද වෙලා හොඳට අහගන්න. Chemical kinetics. Right. Now this is the second part of the physical chemistry. පුතේ හැම දෙනාම හොඳට අහගන්න ඕන. Right? Physical chemistry part එකක් මේක මිස් කරගන්න බෑ. Right? This is the second part of the physical chemistry, right? Physical chemistry. And that one earlier we complete the first part. Right? In first part we had idea about the gases and the energetics. Gases and the energetics. We complete those two. Right? Now second part here, in this second part we have the kinetics, then the equilibrium, then the electrochemistry. Like that way, 11th lesson, 12th lesson, 13th. 14th one is the industrial chemistry, right? So we complete earlier these two lessons. Here we have 3 lesson parts from that one. Now today we start the kinetics, right? When they want to ask a question, they will combine all these, right? Gases, the theories you learn in the gases, right? Energetics, right? Those things are applied in the, especially in the equilibriums, sometimes in the kinetics also, right? Like that way. So all these together, right? 5 lessons there, right? We can have the questions in the essay paper. In essay paper, question number 5, 6, 7. All those from these parts. Physical chemistry, second part, and the first part, right? 5, 6, 7. Then in the structured paper also, right? The third question, that one also from the, right, physical chemistry. So big lesson part. Okay. So earlier we complete these, right? It's better to revise those things also. Now today I will start the kinetics. Right? Physical chemistry parts in those, right? You don't have to remember a lot of things. Special thing is you have to understand those. Right? Clearly you have to feel that one. If you feel the system, if you feel the behavior of the system, then, right, easily we can do the calculations. We can write the answers. But in writing the answers even, right, in a neat way, you have to produce the answer. Therefore, how to write the things, I will clearly indicate here, I will teach here, right? So you have to apply that one, right? Don't, right, miss those things. Don't neglect those things. නසලකාරින් දෙපා කියන පිළිවෙලටම ලියන්න ඕන. කරුණාද ෆිසිකල් වල විශේෂත්වය ඒකයි අනිවාර්යයෙන්ම ආන්සර් එක හරිම නීට් වෙන්න ඕන. කෙටි උත්තර තියෙන්නේ. නීට් ආන්සර් එකක් දුන්නේ නැත්නම් ඕගොල්ලෝ ලකුණු ටික නැතුව යනවා. කරුණාද එඳ මම මේ කියලා දෙන පිළිවෙලටම වැඩ කරන්න ඕන. right? එතන අද උගන්වන ටික අනිවාර්යයෙන්ම අද බලන්නත් අවශ්‍යයි. හරි? Now when we want to study a chemical reaction, right? When we want to study a chemical reaction, we can study a chemical reaction in three ways, right? One way is whether this is a very important idea, right? Later when you are taking the answers for the MCQs, right? When you are taking the answers for the MCQs, right? Clearly you have to consider this idea, right? After discussing this one, I will tell you how you can have the questions. When we want to study a reaction, right, we can think about whether the reaction, say for example, nitrogen, hydrogen, ammonia. This reaction, under the given conditions, of temperature, pressure, like that way, whether the reaction is possible to happen or whether the reaction is not possible to happen. We say that one is the feasibility of the reaction. Earlier in energetics, we learned that one, whether it is possible to happen or not under the given conditions of temperature, pressure, like that. So we can study about that one. We call that one as the feasibility of the reaction. Feasibility of reaction. Feasibility of reaction, right? So feasibility of the reaction, we earlier learn how to decide that one. How? In energetics or in thermodynamics, right? We had the idea using delta G, delta H, delta S. Using those, right, we can decide whether it is possible to happen under the given conditions of temperature, pressure, like that. Feasibility of the reaction. Okay. So we study this one under the thermodynamics. Thermodynamics, if not energetics. Right? So delta G, delta H, delta S. Using those, we can have idea about whether it is possible to happen under the given conditions. Okay. Then next we want to think about when happening the reaction. Now, earlier also you learn before that one. Now, feasibility of the reaction, delta G. With that, we can say whether it is possible to happen or not. Say delta G value in certain reaction, delta G value minus 50. A different reaction, I will say this one as delta G1, delta G2, right? That one is minus 500. Okay. Earlier knowledge. This one is possible to happen because delta G is negative. This one also possible to happen on a given condition. This one is feasible. This one also feasible. But if I ask delta G1 minus 50, delta G2 minus 500. If I say D, second reaction happen rapidly than the first reaction. Whether the statement is true or false. Second reaction happen rapidly than first reaction. True or false? That is not correct. That is not correct, right? දැන් ඔන්න මතක් කරගන්න දරුවනේ ෆිසිකල් කෙමිස්ට්‍රි වල හරීම නීට් එකට තමයි ඉගෙන ගන්න ඕන සහ ආන්සර්ස් ප්‍රොඩියුස් කරන්න ඕන. තේරුණාද? පොඩි වචනයකින් එහෙම වෙන්න පුළුවන් උත්තරේ. ඒක තමයි විශේෂත්වය. Now earlier we learned feasibility possible to mention with the delta G, but we cannot predict any idea about the rate of the reaction. You can remember that one, right? We cannot predict two different reactions. This one happen rapidly, this one happen slowly. I can't say it. Right? So here we can say that it is possible to happen or not, but you cannot express idea about or take idea about the rate of the reaction. Then, like that way, now we can study the reaction in a different way. Now here we decide whether it is possible to happen or not. Delta G with that one. Okay. Then the second way to study the reaction is the extent. extent of reaction. Extent of reaction. Okay, how much the reaction happen? We mix the reactants. In some cases, what happen? Reactants completely pass into the products. On the අහගන්න note එක බොහොම කෙටි. මම ගොඩ කතා කරනවා පොඩි සටහනක් දෙනවා. Physical chemistry එහෙමයි. එහෙනම් හොඳට අහගන්න ඕන. Right? We have a reaction. Right? We mix the reactants. Pass into the product. In some cases, after mixing the reactants, they completely pass into the products. One-way reaction. One-way reaction. Some other reactions, we say this one pass to the completion. In some cases, we say the reaction pass to the completion, but actually all reactants not pass into the products. Instead of that one, some of the reactants pass into the products and reach to an equilibrium. Okay. So when you mix the reactants, we can have the products. In some cases, reaction pass to the completion. In some cases, reactants part of that one into this side and reach to an equilibrium. So pass to the completion mean there we assume that is that one reach to the equilibrium. After having the equilibrium, no further product formation. No further product formation. It is in an equilibrium mean into this side, into the reverse like that. Okay. So two ways to happen the reaction. In some cases, the reactants pass to the products completely into products. 100% conversion. 100% conversion. But when you are learning physical chemistry, as you learned earlier, right? 100% completion actually not happen. 99%. 98%. Like that, when you consider any reaction, later in equilibriums, you can have that idea. Right? That one actually not passes the completion. In doing calculations, we assume. But sometimes 99%, sometimes 98%, sometimes 90%, like that. Okay. Now, when happening the chemical reaction, how much of reaction happen? Extent of reaction happen. If you want to take idea about that one, there we use the right lesson that is equilibrium. Equilibrium. So, in the lesson equilibrium, right, in that one, we want to have idea about how much of reaction happen, extent of reaction happen. To decide that one, like in thermodynamics, delta G, delta H, delta S, here equilibrium, in that one, equilibrium constants. We use that one, equilibrium constant. So later in equilibrium lesson, using equilibrium constants, we can have idea how much of reaction happen. Right, say nitrogen, hydrogen, ammonia. Nitrogen, hydrogen mix there. After mixing the nitrogen and hydrogen, allow to happen the reaction. See, nitrogen and hydrogen react and produce ammonia. Somewhere it reached to the equilibrium. When reached into the equilibrium, say 60% of ammonia from the initial reactants, 60% pass the other side. 60% conversion. Now we say this reaction stop here. Under the given condition, now it is a stopped reaction. Why we say it is stopped? Into both directions, the rates are same. Now, no further formation of ammonia. Now you have a simple idea about the equilibriums, right? Earlier, we learn it, right? So under given condition, 60% conversion. So we can have idea about this one using the equilibrium constant here. Extent of reaction. How much reaction happen, right? So that is under equilibriums. Whether it is possible to happen, how much of reaction happen. Okay. Now equilibrium constant, sometimes in equilibriums they will ask, they produce this much. Now they ask a question related to the speed of this reaction. Using equilibrium constants, we cannot have idea about the speed. Using equilibrium constant, you cannot have idea about the feasibility. Sometimes when they are asking the question related to the equilibrium, but they are asking about the rates. So using equilibrium knowledge, you cannot produce the answer. That is why earlier I told you, this is a very important idea. ඔගොල්ලෝ MCQs වරද්දන්නේ මේ හින්දා. Equilibrium වල ප්‍රශ්න අහනවා අහන්නේ හැබැයි rate එක ගැන. They are asking about the rate. If they are asking about the rates, right, we have to take the answer using the next one, that is kinetics, right? Rates of the reactions, feasibility, extent of reaction, and the rates of reactions. If you want to take an idea about the rates of the reactions, there we use the kinetics. Okay, kinetics. How fast the reaction taken place, right? Rates of reactions, how fast the reaction taken place. That is why earlier I told you, delta G using that one, you cannot predict this one. Sometimes a very fast reaction, whether it is possible to happen or not, using the rate, you cannot take idea about the feasibility. Make a පටලව ගන්න බෑ. Feasibility, separate part. Right? With the delta G, you cannot predict the rates. Extent of reaction here. Right? Extent of reaction, with that, you cannot predict the rates, you cannot predict the feasibility. Like that. So under 3 categories, we can study the reaction. Okay. So earlier we complete this part. In next lesson, you will complete this part. Today we will start this part. Okay. ලියා ගන්න note එකක්. right. මම ඩිස්කස් කරලා ඉවරනකොටම කතා බහ පටන් ගන්න එපා පුතේ. ෆිසිකල් කෙමිස්ට්‍රි වලදී යාළුවා ගාමින් වාඩි වෙන්න මේපා. කතා කරන්න බැරිම තැනකින් වාඩි වෙන්න. හරි? දෙතුන් වතාව එකම කියන්න බෑ. එන්න කතා නොකර බොහොම අවධානයෙන් අහගන්න. මිස් වුණොත් මිස් වුණා. right? ලියා ගන්න. It is possible to study a chemical reaction under 3 categories. Under 3 categories as given below. Under 3 categories as given below. Take down this one. Chemical reactions. මාත් එක්කම ලියන්න. Separate into 3 parts. Feasibility of the reaction. Feasibility of reaction. Feasibility of reaction. Put a dash and write thermodynamics, if not energetics. Thermodynamics. Below that one, within bracket, write delta G, delta H, delta S, delta G, delta H, delta S. Second part, that is extent of reaction. Extent of reaction. We'll learn that one later in equilibrium. Equilibrium. Right, to decide the extent of reaction in equilibrium lesson, we use the equilibrium constant. Equilibrium constant. Put a dash and write capital K. Capital K, equilibrium constant. Then the third category, rates of reactions. Rates of reactions. That is under the kinetics. Kinetics. So here we learn about the rates and the factors effect to the rates. Rates and the factors effect to the rates, right? How fast a reaction taken place, that idea. Right. Now, when you consider a reaction, now say some sort of industrial process, nitrogen, hydrogen, ammonia. Industrial process. When we want to study this reaction, or when consider the proceeding of this reaction, to happen this reaction, we have to consider the feasibility. So, thermodynamically, this reaction should be a feasible one. If it is not feasible, we have to supply the conditions, right, to happen that one until it becomes feasible. For example, say under 25 degrees Celsius, this won't happen. So it is not feasible, right? So we have to convert that one into thermodynamically feasible condition. Thermodynamically feasible condition to supply that one. Say, for example, we increase the temperature. Increasing temperature, we convert delta G into negative, like that. Now, say for example, now under 300 Celsius, now reaction is feasible. Then in another way, we have to give a support, that is earlier thermodynamically. In another way, kinetically, whether that one happen with a desired rate, with a required rate. See, it becomes feasible, but to complete nitrogen, hydrogen, ammonia reaction, to complete that one, it take 1 day, 24 hours. So no use of that one in an industrial process. Then in one way, it should be thermodynamically feasible. In another way, kinetically mean rate, right? Kinetically, it should be a feasible one or a desired, up to the desired rate that reaction happen. So for that one, we have to supply the conditions. Say for example, under 300 Celsius reaction happening, but rate of that one is not enough, slowly happening. Say for example, into that one we add a catalyst. So using a catalyst, what we do, we give a support to the reaction, rate of the reaction increase. So that means, right, when considering industrial process reaction, right, that one should be thermodynamically, right, as well as kinetically, should be favored, right? Thermodynamically favored mean possible to happen it, kinetically favored mean rate of the reaction is considerably high, right? With the desired rate is there. Then we can, right, do that industrial process. Okay. Now, when you consider industrial process, right, industrial process, in any industrial process, industrial chemist කෙනෙක් ඉන්නවා. And a lab there. Ammonia production process, right? In the lab, right, always that chemist study about this reaction. How to do this reaction, how to have maximum yield. He consider feasibility, he consider extent of reaction, and he also consider the rate of reaction. How to enhance those, how to have the maximum yield in a profitable way, right? That is the job of the industrial chemist, in a profitable way. Now, feasibility is possible to increase with the delta G. Say, if you increase the temperature, right? If you increase the temperature up to 300, it is feasible. But if you increase that one up to 500, right, delta G become further highly negative. I increase the temperature up to 500. Think like that. But when I'm increasing the temperature up to 500, according to the equilibrium given there, equilibrium constants with that one, when you are taking the temperature up to 500, earlier yield is 60%. When temperature increase up to 500, yield become 35%. Now, it become more feasible, but yield become less than earlier. Okay, like that way. Therefore, now yield decrease here, possible to happen like that way. In some cases, yield in the earlier place, to increase the temperature, we have to use more money. Temperature ka වැඩි කරන්න. To increase the temperature, have to use money. Right? So additional part of money used there, by that one, increasing yield earlier 60, now it is 65%. 5% increase. 5% increase. 5% increase. But to increase the temperature here, this 5% increase with that, say, I earn 1,000 rupees. රුපියල් 1000ක් හම්බුණා. 105ක් වැඩි කරලා. Right? We earn, right, 5% increase with that earn 1,000 rupees. But to increase the temperature, we have to use 2,000 rupees. Then it is not profitable. It is not profitable. තේරුණාද කියපුදී? I like that way. By considering this one, right? When giving support to this reaction, always have to compare the profit there, whether it is profitable. Sometimes, right, when doing the experiment or when doing the manufacturing process, say pressure. If we increase the pressure, we can have more yield. If we increase the pressure, we can have more yield. When you have the more yield, more money possible, more profit possible. But to increase the pressure, we have to use more money. Then it is not profitable. In such cases, what we do? Under room condition, we do the industrial process. So no use of increasing pressure. I like that way. Not only one part, not only the feasibility, not only the extent, not only the rate. Okay, in some cases, in doing the process, low temperature is favored. If low temperature used there, more product possible. Then low temperature when maintaining more product possible, but the rate of the reaction is slow. It take more time. Okay, the rate is low because when you are increasing the temperature, rate increasing. When you are decreasing the temperature, rate decreasing. So under low temperature, more yield possible, but rate of that one is less than earlier. In such cases, what we do? To increase the rate, we give additional support using a different way. Using kinetic knowledge, we add a catalyst to that place. Maintain a low temperature and apply a catalyst. Like that. Okay, therefore, deciding this one is not a simple process. So how to study that one in 3 ways, right? And how to combine it in the industrial process. With that, right, later when you're learning the industrial chemistry, finally we learn, right? When doing this industrial process, what are the optimum conditions we can apply? This temperature, this pressure, this right catalyst like that, the optimum conditions. With that, how to have the maximum profit. Right? Now when consider a reaction, proceeding reaction, we have to give, it should be thermodynamically favored and also it should be kinetically favored. ගොඩ විස්තර කතා කරනවා පොඩි නෝට් එකක් දෙනවා ෆිසිකල් වල ස්වභාවය ඉන්න අහන් ඉන්න අහන් හිටියේ නැත්තම් ඉවරයි to take place a chemical reaction it must be to take place a chemical reaction, it must be both thermodynamically and kinetically favored under given conditions such as temperature and pressure of the system next line asterisk mark temperature and pressure of the system asterisk mark to form the amount of desired product reaction must be thermodynamically favored. Underline amount of desired product thermodynamically favored. Another asterisk mark. To complete the reaction, within the desired time period, To complete the reaction within the desired time period, comma, it must be kinetically favored. Must be kinetically favored. Right? Desired time period, underline that one, kinetically favored, underline that one. Therefore, control of a reaction, below those 2 points, control of a reaction. We have to consider 2 categories, right? Thermodynamics. තාම පාඩමට අවතීර්ණ වෙනවා. Mean delta G, delta H, delta S. Right? Then kinetics. වෙන කතා බහ නම් කරන්න එපා. කොහොම කරුණාවෙන් කියන්නේ ඈ? මේක ඕගොල්ලෝ කොහොම ඉගෙන ගත්තත් තේරුණාද? හොඳට අහන් හිටියත් බොහොම අමාරුවෙන් තමයි ඔළුවට ගන්නෙ. මේකේ කාරණා ගොඩක් තියෙනවා පුතේ. දැන් මේ හදලා දෙන නෝට් එක තියෙනවානේ, මේ නෝට් එක ඔයගලන්ට තාම තේරෙන්නේ නැහැ ඔය ගන්නවට. ඔයගොල්ලෝ තේරුණා කියලා හිතුවට තේරුන්නේ නැහැ. මේක 100%ක් තේරෙන්නේ නැහැ. මේ නෝට්ස් හදන්නේ පුතේ මේක ලෙසන් එක ඉවර වෙලා ආපහු මේක මුලින් ඉඳන් බලනකොට තමයි ඔයගලන්ට. ඒ කියන්නේ මේ ලෙසන් එක විතරක් නෙමෙයි, කයිනෙටික්ස්, එනර්ජෙටික්ස්, ඉක්විලිබ්‍රියම් වැඩ තුනම ඉවරනාට පස්සේ මේ නෝට් එක බලපුවාම තේරෙනවා. ඒක රිසෝස් එක ලියලා තියෙන්නේ එහෙමයි. දැන් ඔයගොල්ලෝ රිසෝස් එක කීවට තේරෙන්නේ නැහැ. තේරුණා කියලා හිතුවට තේරිලා නැහැ. තේරුණාද? මම කියන්නේ ෆිසිකල් කෙමිස්ට්‍රි. රිසෝස් එක හදලා තියෙන්නේ මුළු ඔක්කොම දන්නවා නම් දන්න කෙනෙක් කියවපුවාම තේරෙන විදිහට. එහෙනම් ඔයගොල්ලන්ට එකපාරට ඔක ගන්න බෑ ඔළුවට. හරිද? සමාජයට පාඩමේ එහා පස්සේ උගන්න දෙයක් ඉස්සරහා නෝට් එකේ ලියලා තියෙනවා. ඉදිරියේ. දැන් මේවත් මම තාම උගන්ලා නැහැ නේ. කයිනෙටික්ස් උගන්ලත් නැහැ, ඉක්විලිබ්‍රියම්ස් උගන්ලත් නැහැ. තේරෙනවද? එතන නමුත් පොඩි අදහසක් දෙනවා ඔයගොල්ලන්ට මෙතනදිත් මෙන්න මෙහෙමයි මේක කරන්න ඕන කියන එක. පාඩම අවසානට ගිහිලා ආපහු එන්න ඕන. තේරෙනවද? එන අවබෝධයෙන් යන්න ඕන. දැන් ඔයගොල්ලන්ට තේරෙනවනේ මම කියලා දෙනකොට ගොඩ වෙලාව ගන්නවා නෝට් එකේ චූට්ටයි. පොඩි ප්‍රමාණයයි. හරි? එන අවධානය වෙන වෙන පැතිවලට යොමු කරගන්න එපා. කතා කරනවා කියන්නේ ඔයගොල්ලන්ගේ අවධානය බිඳෙනවා. හරිද? එතකොට තේරුන්නේ නැහැ කියවට මට කියන්න තියෙන්නේ සෝරි කියලා විතරයි. බොහොම හිමීට මං සීරුවට පාඩම හදනකොට ඔයගොල්ලෝ එහෙම ගියොත් අවධානය ඉවරයි. හරිද? Kinetics. මෙතන ලියා ගන්න right rates and the rates. EA like that write that one activation energy. තාම දන්නේ නැහැ නේ ඔම ලියලා තියන්න. Activation energy. Rates, activation energy. Now I will pass to the kinetics lesson. Then the on the පාඩමට එන්නේ. What is mean by chemical kinetics? What is mean by chemical kinetics, right? If we study about the rates of the chemical reactions. You are studying about the rates of the chemical reactions. And you are studying about the factors effect to the rates. What's mean by a rate? How to define that one? Right? Some reactions are fast reactions, some are slow reactions. Like that, study about the rates. Then how to control the rates? Factors affect the rates, and using the factors, how to control it. Controlling rates. So study about these, collectively called as the kinetics. Leon, separate paragraph. Study about the rates of chemical reactions comma, factors affect the rates of chemical reactions, factors affect the rates of chemical reactions, and how to control the rates. And how to control the rates, control the rates by changing the conditions, are collectively known as chemical kinetics. Chemical kinetics. Take down this one also. Pauli aga na mehemat. Rates of chemical reactions, factors affect the rates, controlling the rates by changing conditions. Okay. Below this, as a paragraph, write this one. Therefore, industrial chemists, therefore, industrial chemists are interested, industrial chemists are interested about the kinetics of reactions. Interested about the kinetics of reactions. Kinetics of reactions. Because rate of a manufacturing process, because rate of a manufacturing process, online rate of a manufacturing process, is a very important factor, to carry out the industrial process, profitably, to carry out the industrial process profitably. Example, nitrogen, 3 hydrogen, nitrogen gas, 3 hydrogen gas, 2 ammonia gas. Now, when you consider this industrial process, right? Write the physical states. Now, this is a physical chemistry lesson. No? Kinetics, equilibrium, early energetics. In all cases, if you know the physical state, in all cases, if you know the physical state, in all cases, when writing the components, how to write the physical condition, physical state. Aniwaren liviya yuthuයි. Hari? Now, this industrial process, so to do this one in a profitable way, right? We control the conditions such as temperature, pressure, catalyst, like that. Clear? In ammonia manufacturing process, conditions such as temperature, pressure, and catalyst. Temperature, pressure, and catalyst. Are controlled to do the process more profitably. To do the process more profitably. Right, next topic. Next topic. Reaction rates. Then on api පාඩමට අවතීර්ණ වෙලා. Reaction rates. Topic is that one. Right. Now, when you consider chemical reactions, right? After mixing the reactants, we have a system, mix the reactants. As told earlier, right? Reactants, now these can pass to the products. In some cases, this one passes the completion. In some cases, that one reaches to an equilibrium. Pass the completion and stop that one. If not, reach the equilibrium and stop that one. Okay, stop mean no further product formation. No further product formation. Okay, so 2 ways to complete the reaction. In some cases, pass the completion. In some cases, reach to the equilibrium. Okay, now when you consider chemical reactions, right? Some chemical reactions, after mixing the reactants, within a fraction of a second, sometimes 10 to the power minus 12 second, minus 12 to minus 18, like that. Very short time period. Within a very short time period, that one complete the reaction. maybe reach to the equilibrium, maybe pass to the completion. Okay, then we say they are very fast reactions. Very fast reactions. Kalpanayen ahagana. Right? Now, for example, say hydrogen and oxygen mixed together. And we supply the reaction conditions. Conditions dunna, not in room temperature. Then hydrogen and oxygen rapidly react and give the product. So some are very fast reactions. We mix the reactants and allow to happen the reaction. That one happening, and sometimes within our lifetime, we cannot observe the completion of the reaction. Reaction is feasible, delta G negative. But time period take to that one to complete the reaction, it is a long time period. So we say they are slow reactions. Some reactions, after mixing the reactants, right? For the earlier one, another example. Now, when you consider, say, for example, the corrosion, right? We have the iron, we supply the reaction conditions, right? Water vapor is there, oxygen is there. Now taking place the reaction. But it take a long time, a slow process. We say it is a slow reaction. Okay. In some cases, when you're doing the experiments in your lab, after mixing the reactants, you can observe within 1-2 minutes, right? The products given there. We say they are with a moderate rate. So some are fast reactions, some are very slow reactions, some are happening with a moderate rate. So we can categorize the reactions into 3 types with respect to what? The time taken to complete the reaction. So we say the fast reaction, we say the slow reaction or a moderate reaction with what? How much of time used to complete the reaction. When I say complete the reaction, feel that one in 2 ways, pass to the completion or reach to the equilibrium. Okay, so time is the factor there. With the time, we say some are fast reactions, some are slow reactions. Whether we categorize the reactions into 3 types as instantaneous reactions or the very fast reactions. Instantaneous reactions or the very fast reactions. The other type, very slow reactions. The other type, moderate reactions. Okay. Then actually later in kinetics, we will study about those moderate reactions. Okay. Very fast reactions within fraction of a second, that one pass to the completion. So in our lab conditions under that one, actually we cannot study that one. Though we are not studying this. But very fast reactions also there. Okay. Now, when you consider a reaction, later you can learn that one. If you increase the temperature, if you increase the temperature of the system, definitely the rate of the reaction increase. Definitely the rate of the reaction increase. In all syllabus, if I give the statement like this way, when temperature increasing, rates of all chemical reactions increase. In all syllabus, we have taken that one as a true statement. It is a true statement. But now when you are learning the kinetics, when temperature increasing, rates of the reactions increase. It is all right, but not in all reactions. If they say all reactions, we take that one as a false statement. Reason is instantaneous reactions 10 to the power minus 12 second like that, very small time period, with that it passes the completion. You increase the temperature from 25 to 50. Change in the rate, they also change, but change in the rate is negligible. 10 to the power minus 12 earlier, now 10 to the power minus 14. It is not measurable in one way, in another way, it is not a considerable change, negligible change. Because of that one, because of the instantaneous reactions, very fast reactions. Now we say, right, when increase in temperature in all chemical reactions, rates increase. That is not correct. Unlike that, therefore, very fast reactions even in learning the kinetics, important. But very fast reactions, study about the kinetics of that one is not in our level. Therefore, we do not study that one. Then the opposite of that one, very slow reactions. In our lab condition, we cannot wait there. We have to wait for our lifetime in the lab to observe the completion of the reaction. Right? So therefore, very slow reactions, they are also not studied, right, under the kinetics. We will study about the reactions happening with a moderate rate. Within 1-2 minutes, we can observe the product formation, like that, a moderate rates. So we study about that one. So in this lesson, under the chemical kinetics, we will study about those moderate reactions. But two other ways possible with that, when you are taking the answers for the MCQs, we use those ideas also. එහෙම නැතුව නෙමෙයි, ඒව ගැනත් හිතලා තමයි උත්තර තෝරන්නේ. තේරුණාද? ලියා ගන්න. Topic is reaction rates. Under that one, reaction rates are different in different chemical reactions. Are different in different chemical reactions. Some of the chemical reactions pass to the completion. Or reach to the equilibrium. Pass to the completion or reach to the equilibrium within a very short time period. Within a very short time period. Within a bracket, right? Fraction of a second. Close bracket. And some of the reactions pass to the completion within a long time period. Within a long time period. Within a bracket, right? Thousands of years. Thousands of years. Full stop. Therefore, by considering the time period, consumed to complete within a bracket or reach to equilibrium. within a bracket or reach to equilibrium, close bracket. Chemical reactions are classified sentence complete to name the bracket taking pass. Therefore, by considering the time period consumed to complete chemical reactions are classified into three types. Into three types as explained below. Into three types as explained below. Number one, very fast within a bracket instantaneous reactions. Very fast instantaneous reactions. Atisigra patikriya, shanika patikriya. Right? And that these reactions are very fast. These reactions are very fast. Are very fast and occur as soon as the very fast and occur as soon as the reactants are brought together. As soon as the reactants are brought together. We mix the reactants mean products are there. How to identify? A very fast reaction. Usually very fast reactions involve the reactants in ionic conditions. Ionic species. Reactants are in ionic species as appear as ionic species. Those reactions, usually they are very fast reactions. So they can produce a statement. They can give you example. Silanitrate aqueous. Sodium chloride aqueous. Silver chloride precipitate. Sodium nitrate. Reactions involving ionic species. Usually these reactions, right, they are very fast reactions. Okay. Why they are very fast? Because in such reaction, the only thing happen, like you learn strong acid, strong base reactions, silanitrate aqueous means Sil plus ions and nitrate ions. Sodium chloride aqueous solution means sodium ions, chloride ions. Sodium nitrate means sodium ions, nitrate ions. Only thing happened there is you mix the two components mean silver ions and the chloride ions join together, silver chloride produce. Only thing happened there is the silver chloride ionic bond formation. No bond dissociations. Now earlier reaction nitrogen, ammonia, if you consider that one, nitrogen nitrogen bonds break, hydrogen hydrogen bonds break, then nitrogen hydrogen bonds newly producing. Right? So breaking bonds, forming bonds, two things happen there. Here, only thing is formation of the bonds, ionic species, just join that one and give the product. Therefore, very fast reactions or the instantaneous reactions, for that one important example type is the reactions involving ionic species. They are very fast reactions. The other example I can give there, that is acid-base reactions, strong acid, strong base neutralizations. They are also very fast reactions. Okay, in our level, we take those. Okay, liya asterisk mark can write. These reactions involve ionic species. These reactions involve ionic species, comma, hence called as ionic reactions. Hence called as ionic reactions. Examples. Formation of a precipitate of silver chloride. Formation of a precipitate of silver chloride. Take down this one. Silver nitrate, sodium chloride. Below that one in this ionic form also write that one. Metangolat liyaga. Silver nitrate, sodium chloride, silver chloride, sodium nitrate. Take this one as the first example. My example calling statement एक underline करगन. Reactions involve ionic species. Ionic reactions, they are very fast. Underline that one. Then the second example. Second example. First write that one as a sentence. Neutralization of strong acids. Neutralization of strong acids with strong bases. Strong acids with strong bases in their aqueous solutions. Strong acids with strong bases in their aqueous solutions. Aqueous sodium hydroxide, aqueous HCl. Sodium hydroxide aqueous. Mean actually that one present as sodium plus. Lian and OH minus. HCl aqueous mean H plus Cl minus. Mix together sodium chloride aqueous sodium ions, chloride ions. H2O liquid. below this, right? Instantaneous reactions. Instantaneous reactions pass to the completion. Instantaneous reactions pass to the completion within a fraction of a second. Within a fraction of a second. Within a fraction of a second. Within a bracket, right? 10 to the power minus 12 to 10 to the power minus 18 second. Very small time period. That is why earlier I told you, as soon as the reactants, right, mix together, product is there. Right? Next line with asterisk mark. It is impossible. It is almost impossible. Correct, like that. It is almost impossible to determine the rates. Almost impossible to determine the rates of these reactions by usual techniques. By usual techniques. Next topic. Very slow reactions. Second type. Very slow reactions. Very slow reactions mean some reactions, right, happen in a very slow rate. Slow reactions. Sometimes under the given conditions, say under room temperature condition, under room condition, some of the reactions happen very slowly or sometimes never happen, like that. But if you supply the condition, say for example, temperature, such a reaction, if you take the temperature up to a high value, then sometimes they will happen rapidly. Sometimes with explosions, possible to happen. Hydrogen, oxygen mixed together in room condition, no reaction. But under high temperature, rapidly happen the reaction, like that. Very slow reactions. Okay, Leagan. Very slow reactions under that one. Some of the chemical reactions occur in extremely slow rates. Occur in extremely slow rates. Slow rates. And sometimes never happen under room temperature conditions. Never happen under room temperature conditions. Next line. Very slow reactions take a long time to pass to the completion. Take a long time to pass to the completion or reach to the equilibrium. or reach to the equilibrium. Leave one line and write. Most of these reactions usually not happen at room temperature. But some of those happen very fastly. Some of those happen very fastly at high temperature conditions. At high temperature conditions. Examples. Reaction between first example, right? Reaction between hydrogen and oxygen not happen at room temperature. Not happen at room temperature. But this reaction is highly explosive, around 1000 Kelvin temperature. Around 1000 Kelvin temperature. Second example. Reaction between carbon and oxygen. Reaction between carbon and oxygen. Not happen at room temperature. Not happen at room temperature. But carbon but carbon within a bracket coke, we say that one, coke. But carbon, coke, catch fire rapidly at high temperature conditions. At high temperature conditions. Next line, asterisk mark and write. It is also difficult to study the kinetics it is also difficult to study the kinetics of very slow reactions. Difficult to study the kinetics of very slow reactions because it take a long time to give the observations. Long time to give the observations. Number 3, moderate reactions. moderate rates. Reactions having moderate rates. So reactions happening with a measurable rate. Lian. Most of the moderate reactions taken place at a moderate and measurable rates. Moderate and measurable rates at room temperature. At room temperature. And therefore it is possible to study the kinetics. Possible to study the kinetics of these moderate reactions under laboratory conditions. Examples. First example, decomposition of hydrogen peroxide. Decomposition of hydrogen peroxide. H2O2 decomposition. Write it up. Reaction. Hydrogen peroxide aqueous. 2H2O liquid. O2 gas. Second example. Decomposition of nitrogen pentoxide N2O5. Decomposition of nitrogen pentoxide N2O5. N2O5 into N2O4 and oxygen. N2O5 N2O4 oxygen. Third one, hydrolysis of an ester. Hydrolysis of an ester. AC එක වැඩිද ඔක? ඔය AC එක අඩු කරන්න බෑ, ඕෆ් කරන්න තමයි වෙන්නේ. බලමු. උත්සාහයක් දරමු. Decomposition of N2O5. මොකද කිව්වේ? Hydrolysis of an ester. මේ බලන්න පුතේ. හරි. දැන් පන්ති ආද මේ ගොඩක් ඒ ඔය AC එකත් මම දාන්න කිව්වේ මේ කට්ටිය අද ගොඩක් ඉඳී කියලා. වෙයි නම් කට්ටිය නෑ නේද? විවේකීව ගෙදරට වෙනවා. වැඩි හරියක් ඔන්ලයින්. මේ බලන්න. ester CH3CO O C2H5 R CO OR dash commonly we write like this way. Armin alkyl group. Right? Ester. If you use sodium hydroxide, if you use sodium hydroxide, we can break this ester. Ester produced by the carboxylic acid, RCOOH, and the alcohol. When add the sodium hydroxide, right? When you use sodium hydroxide, this one break into two parts. They get produce carboxylic acid, RCOOH, and produce the alcohol, CH3. Carboxylic acid and the alcohol, C2H5OH. When happening that hydrolysis, carboxylic acid produce, but the medium is basic here. You are using sodium hydroxide. Therefore, carboxylic acid, acid cannot exist there, acid convert into its salt, acid anion, O minus, Na plus, like that. Carboxylic acid, sodium hydroxide, acidic sodium hydroxide, sodium acetate produced like that. So, hydrolysis of hydrolysis of the ester. Break here carboxylic acid and the alcohol. Give their carboxylic acid in sodium hydroxide medium that cannot exist. They have produced the salt. COO minus Na plus and the C2H5OH. Liagan. Aqueous. මෙහෙමත් ලියන්න. ඉක්මනින් ලියා ගන්න. ester with the sodium hydroxide. Carboxylic acid convert into anion, O minus Na plus, alcohol, C2H5OH. Right? Next example. Reaction between ferric chloride and potassium iodide. Reaction between ferric chloride and potassium iodide. Ferric chloride, FeCl3, and potassium iodide, Ki. We'll write the ionic reaction that is enough ferric iodide, ferric to ferrous, iodide to iodine. Ferric to ferrous, iodide to iodine. The reactions we can study moderate reactions. Reactions having moderate speeds. Next example. How many reactions? Tacticals theonomic. Next example. Reaction between sodium thiosulfate and nitric acid. Practical rate Next one, last example, reaction between sodium thiosulfate and nitric acid. Sodium thiosulfate and nitric. ලියන්න බලන්න reaction එක. Sodium thiosulfate HNO3. Sodium thiosulfate HNO3. This one also for a practical. Sodium thiosulfate 2 nitric. Sodium nitrate, 2 sodium nitrate. 2 hydrogen and H2O3. 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 H2SO3. H2CO3. H2CO3 carbon dioxide water. H2SO3 sulfur dioxide water. H2S2O3 sulfur dioxide sulfur water. අතිපදා උගන්ලා තියෙනවා plus sulfur dioxide sulfur water. We need this reaction also later to study the kinetics. Below this, it is possible to study the kinetics, of above moderate reactions. By changing the conditions such as temperature, pressure, concentration and catalyst. Temperature, pressure, concentration and catalyst. Come on, because it is possible to have observations within a desired time period. Okay. Next topic, rate of a reaction. Rate of a reaction. නැවතීමක් නෑ. දවස් 4න් 5න් ඉවර කරගන්න ඕන වැඩි. අමාරුයි වැඩි. ගිය අවුරුද්දේ මේ විභාගේ ලියන අයට දවස් 8ක් විතර ගියා ඉවර කරන්න. 8කුත් මදි වුණා. ඒ තරමට තියෙනවා දැන් කයිනෙටික්ස් උගන්න. ඉස්සර දවස් 4න් මාසෙන් ඉවරයි. හරිද? පොඩි points ගොඩයි. ඒව දීලා තියෙන ඉතින් just mention කියලා just mention කරන්න බෑ. හරි. එහෙම කරන්න බෑනේ එහෙම උගන්නන්න බෑ. Rate of reaction. ලියා ගන්න topic එක rate of reaction. Now when you have given reaction, we'll take a simple one. P into Q. Reactants, products. මං කිව්ව වෙන අවදාන වලට යන්න එපා කියලා. Right? Reactants into products. Rate of the reaction. Now I can express the rate of the reaction. I can express the rate of the reaction in two different ways. When proceeding the reaction, reactants are consuming. Reactants are consuming. At the beginning, I had say 10 moles of P. At the beginning, 10 moles. With the time, what happened? Amount of P decreasing. Mean we can express the idea about the rate of this reaction as the reactant consuming rate. Reactant consuming rate. In another way, at the beginning, product is not there. Q is not there. Q is 0. With the time, with that, what happened? Q producing. Therefore, products forming rate. So in two different ways, we can express the rate. Within a time period, how much of reactant consumed? Then amount of reactant consumed we divide by the time. Then within a unit time, reactant, how much reactant consumed? Reactant consuming rate. Rate I mean within a unit time, how much of reactant consumed? Time එකෙන් බෙදනවා. අතර unit time එකට එනවා. ඒ කියන්නේ rate එක. ශීඝ්‍රතාවය. හරිනේ? So in two different ways, therefore we can think about the rate of the reaction. Reactants with that we can consider, products with that we can consider, reactants consuming rate like that, if not products forming rate. Take down the note. It is possible to express the rate of a chemical reaction, express the rate of a chemical reaction in two ways. By concerning the amount within a bracket, right? Concentration. Later we will take that idea, concentration, right? First I will start with the amount. But to complete the note, you write that one. So amount within a bracket, concentration, close bracket, of the reactants or the amount within a bracket again, concentration, close bracket, of the products. Amount of the reactants or the amount of the products. Memali another reactant, right? Reactants into products. Memali agan on the arrow right rate. Below that one, put number 1 and write number 1. The rate of decrease in rate of decrease in amount. Rate of decrease in amount backslash concentration. One of those. Decrease in amount, not concentration of any one of the reactants. Of any one of the reactants. Any one of the reactants. O. Number 2. The rate of increase, same as earlier, in amount, if not concentration, of any one of the products. Of any one of the products. Any one of the products, put a semicolon there. Then to the next line, at a constant temperature. At a constant temperature. So on a constant temperature condition, we can consider maybe one reactant, maybe number of reactants. Say for example, A plus 2B, C plus 3D. Rate of this reaction possible to express using this one. Okay. Rate of consumption of A. Rate of consumption of B. If not rate of formation of C, rate of formation of D. Okay. By considering the amount, we can express the rate. If not by considering the concentration, we can express the rate. So at the beginning with the amounts, I will start it, but we finalize that one with the concentration. Finally, rate of a reaction, we always express as the concentration change per unit time. Moles per cubic decimeter per second, like that. Change in concentration divide by time period, like that. Hari? Leave line and write. Consider the following. Consider the following general reaction. Consider the following general reaction. Next line, assume that the temperature and the volume of the system, temperature and the volume of the system is constant. Temperature and the volume of the system is constant. Temperature and the volume of the system are constants. Are constants. Take down the reaction. මේ පැත්තෙන් පොඩි ඉඩක් තියලා ලියන්න. A into B. A into B. Time period, right? 0, t equals 0 at the beginning, initial, that idea. Amount of V, I will mark that one as NA. Amount of V, NA. Leander. Amount of B, NB. in A and B. To take the idea initial, I will use I. I will use I. NA, N mean amount A, amount of A at the beginning, amount of B at the beginning. Time pass up to T. T time pass. NA at the time T. Okay. NB at the time T. අපි මෙයාගේ ලියන්න යන්නේ rate එක. ලියන්න. By considering the reactant A, by considering the reactant A, semicolon. Next line has a statement, right? Rate of change in amount of A. Amount of A. Okay. How you are taking the difference? Right? How you are taking the difference? Always you are taking a difference, that is final one minus initial one. Final one minus initial one. Therefore, finally, this one, NAT. Amount of V at T time minus amount of V at the beginning, initial, divide by final time T, T minus 0. ලියන්න ඕන එක T විතරක් ලියලා බෑ. T minus 0. Okay. Write it. Okay. Here, amount of A difference. When you are taking this difference, right? Final one, initial one, like that, a difference. I can mark that one as delta NA. Amount of A, delta mean change. Change in amount of A. Time difference, I will take that one as delta T. So I can take this one is like this way. But when you are taking this one, right, we get a negative answer. We get a negative answer. Why? Final one is less than the initial because reactants are consuming. Right? Then in your syllabus, anywhere, everywhere, when you want to express the rate of a reaction, always you indicate that one as a positive quantity. In all cases, rate of the reaction expressed as a positive quantity. Negative answers end the back. In all syllabus, if you are not writing the negative sign, no marks. Reactants consuming, therefore minus sign should be there to have the marks. A parana syllabus. හරිද? ඉස්සර ඍණ ලකුණ දැම්මේ නැත්නම් ලකුණු දෙන්නේ නැහැ. දැන් ඍණ ලකුණ දැම්මොත් ලකුණු දෙන්නේ නැහැ. හරිද? ඒකයි මම දැන් කිව්වේ මොකද්ද? Always as a positive quantity. Okay, therefore to have a positive answer, artificially we use the negative sign. This is the idea. This is how to take the answer. Very simple questions. Sometimes in structured paper, how we are collecting the answer with that. Sometimes you can have the marks, sometimes you cannot have the marks. දැන් එක අවුරුද්දක question එකක් තියෙනවා මේ මෑතක මෙහෙම ලියන්න. මේක ලියන්න දෙයක් නෑ. ඒක රේට් එක දීලා තියෙන්නේ එතන. ඒ වුණාට වෙනස් කරලා වෙන් කරලා ලියන්න ඕන මෙහෙම. මේ substitution එකට වෙනම ලකුණු 10යි. ඒක ලියනවට. මේ මොනවත් ලියන්න නැතුව කෙලින්ම උත්තරේ ලියයි. අපිට ඒක තියෙනවා ඒකේ උත්තරෙත්. question එකේ. හැබැයි ඔයගොල්ලෝ කොහොමද වෙනස ගන්න? How you are taking the difference, have to indicate that one substitution in that place like this way. With that given values, right, you have to write it. ඉදිරියේදී pass papers කරද්දී හම්බෙයි. ඒතර ඒක ලියනමට වෙනම ලකුණු තියෙනවා. උත්තරේ යාර ගන්නවට වෙනම ලකුණු තියෙනවා. හරිද? එන්න මේ මං කිව්වේ අර පටන් ගද්දිම physical chemistry වල ලකුණු තියෙන්නේ. ඔයගොල්ලෝ කොහොමද උත්තරේ කලෙක්ට් කරන්නේ? නිකන් උත්තරේ ලියුවට බෑ. ඔයගොල්ලෝ concept එක දැනන්ද ලියන්නේ. මේ ලියන්නේ concept එක. Final one, initial one, final time, initial time difference. ඒව ලියනකොට ලකුණු තියෙනවා. ඒතර බිඳුවත් මම ලියන්න කිව්වේ ඒකයි. දැන් මේ question එකේදීත් බිඳුව ලියනවත් එක්ක තමයි ලකුණ තියෙන්නේ එතන. අන්න ඒ වගේ. හරිද? අපි මෙන්න මෙහෙමයි ගන්න. ඒ කියන්නේ ඒගොල්ලෝ ඉල්ලන්නේ මොකද්ද? හරිම concept එක. ඔයගොල්ලෝ ඒක හරියට දැනගෙන තියෙනවා. දැන් answers ගත්තෙත් right මෙතන මේ negative sign එක දා ගන්න ඕන වෙනම right separately have to take that one with that we have to have a positive answer. Okay මේ උඩ එකේ right මෙතන මීඩ තියෙනම් උඩින් ලියන්න එහෙම නැත්නම් පහළින් ලියන්න equal minus delta change in amount of V like that way delta T. Minus sign එක ඕන red pen එකෙන් ලියලා තියාගන්න. We put that one artificially because of the reactants. Then below that, right? Because the reactants are consuming, we get a negative value. We get a negative value for the change in amount of V. Negative value for the change in amount of A. But red pen. Changing amount in any chemical process. Change in amount of any chemical process is considered to be a positive quantity. Considered to be a positive quantity. Has a negative sign. Hence, a negative sign is artificially used. When expressing the rate of a reaction. When expressing the rate of a reaction using reactants. Next line. Therefore, rate of changing, rate of changing amount of reactants change in amount of reactant equal minus delta Na delta T. Any reactant you can consider there. Next line. By considering products, comma, using B. By considering products, comma, using B. Learn the rate of change in amount of B rate of change in amount of B equal in the usual way. First you substitute it. What is that? NB T NB initial divided by T minus 0. Delta NB divided by delta T. Next. Therefore, the rate of the above reaction can be given as, therefore, the rate of the above reaction can be given as rate equal rate of the reaction. Rate of the above reaction can be given as, put semicolon and to the next line, rate of reaction equal minus delta Na delta T equal delta NB divided by delta T. Harida, reactants consuming, products forming. With the reactants, with the products. Hari? තෙරුණානේ? උගන්ලා දෙනකන් ඉන්න ඕන හැබැයි ඈ යොසීමේ. මං කියලා තියෙන්නේ ෆිසිකල් කෙමිස්ට්‍රි ඉගෙන ගන්න යනවා නම් හිස් ඔලුවක් එක්ක එන්න. හරි? කුරුවල් වෙච්ච ඔලුව වලට උගන්වන්න අමාරුයි ෆිසිකල්. හරි එතකොට ඔයගොල්ලෝ කලවම් කරගන්න ඔක්කොම. දැන් මම මේක ලියද්දි මේක කලින් කවුරු හරි දාන්න කෙනෙක් ඉන්නවනම් පොඩි ඩවුට් එකක් තියෙනවා දැන් මෙතන. ඒක ඉතින් මට කරන්න දෙයක් නෑ. තාම උගන්ලා ඉවර නෑ. right? ඒකයි මං කිව්වේ. කියලා දෙන ටික 100%ක් ගන්න. පාඩම ඉවරුනහම ඕන දෙයක් අහන්න. right? පාඩම ඉවරුනාට පස්සේ ඈ. right. Write like this way. Below this one, right? The variation of rate of the reaction. The variation of rate of the reaction. Rate of the reaction. Reaction, comma, A into B. A into B can be illustrated by the following figure. can be illustrated by the following figure. What is the plot? Here amount within a bracket, right? N amount, moles, that idea. X-axis time. Time, with the time what happened? Now when you consider this reaction, later you can learn this fact. Till that, now when the concentration of a reactant is high, rate of that one is high. When the concentration of a reactant is low, rate of that reaction is low. When concentration high, reaction happen rapidly. මුතේ පාඩමේ ඉන්න අවධානය නැති කරගන්න එපා. ෆිසිකල් කෙමිස්ට්‍රි ගෙදර ගිහින් පාඩම් කරන්න බෑ. නෝට් එක තියෙනවා. ෆිසිකල් කෙමිස්ට්‍රි පන්තියේදී ඉගෙනගෙන යන්න. දැන් ඉනෝගනික් වගේ මග ඇරුණොත් ගිහින් හරි පාඩම් කරගන්නම් කියලා ඉඳලා හරියන්නේ නැහැ. එහෙම කරන්න බෑ. හරිද? ඉඳ අවධානයෙන්ම ඉන්න. Right? If the concentration of this one is high, rate is high. If the concentration is low, rate is low. Later we can learn it, how it happens. ඔක්කොම ගන්නනවා. Till that. Therefore now at the beginning only A. At the beginning only A. So A rapidly consuming. At the beginning A rapidly consuming. When rapidly consuming, A concentration rapidly decreasing. Can all feel it? At the beginning 10 moles per cubic decimeter, if not 10 moles. Then it 10 moles. Rapidly decrease that one. Rapidly decrease that one mean amount rapidly decreasing, concentration rapidly decreasing, rate also, rate consuming rate decreasing. Okay. When concentration of the amount is high, rate is high. Rate එක ගොඩක් වැඩි කියන්නේ වේගෙන් යා වැය වෙනවා. Rate එක අඩු වෙනවා කියන්නේ හිමීට වැය වෙනවා. හරිද? එහෙනම් here when you are drawing the plots, right? At the beginning rate is high. Amount difference divided by time period mean the gradient. Gradient. So at the beginning gradient is high. But with the time gradient decrease. Therefore we get this kind of variation. Any තේරුම් ගත්තද? If I consider the gradient here, it is like this way. It is like this way. It is like this way. Gradient decreasing. හරිද? මේක අහන් ඉන්නවා වගේම කටපාඩම් කරන්න බෑ පුතේ. When the concentration high, rate high, consuming rate high. එහෙමනේ feel එන්න ඕන ඔයගොල්ලන්ට. High concentration rapidly happen the reaction. Rapidly happen the reaction mean rapidly consuming that one. සීඝ්‍රයෙන් වැය වෙනවා. Okay, like that. So it is like this way. That is Na. Parallel to that one, A consuming mean B at the beginning rapidly B forming. මෙයා වැය වෙනවා කියන්නේ මෙයා හැදෙනවනේ පුතේ. එහෙනම් මෙයා සීඝ්‍රයෙන් වැය වෙනවා නම් මෙයා සීඝ්‍රයෙන් හැදෙනවා. At the beginning rapidly producing, but with the time forming rate also decrease. Okay, because of that one, at the beginning 0, with that it is like this way. Gradient, when you consider that one, gradient decreasing like that way. So that is NB. තේරුම් අරන් මේව කටපාඩම් කරලා වැඩක් නැහැ. Rapidly decreasing but later slowly. දැන් අන්තිමට තියෙන්නේ පොඩි ප්‍රමාණයක් නම් දැන් ඒ පොඩි ප්‍රමාණයක් තාම යනවා. හැබැයි දැන් යන්නේ හිමීහිට. තේරෙනවද කියන එක? ඉතල ගොඩ ප්‍රමාණයක් තිබ්බයි වේගෙන් අඩු වෙනවා. 20ක් තිබුණා කියලා හිතන්න. 20ක් තිබුණා. 20 10 වෙන්න තප්පරයයි ගියේ. කියලා හිතන්නකෝ. තප්පරයකින් 10 වුණා. හරිද? ඊළඟ තප්පරේදී 5ක් වෙන්නේ නැහැ. එහෙම නැත්නම් ඊළඟ තප්පරේදී බිඳුව වෙන්නේ නැහැ. එන්නේ මොකද වෙන්නේ? වේගය අඩු වෙනවා. එහෙනම් ඊටු ටික අඩු වෙන්නේ එමීට. ඊළඟ ටික ඊටත් වැඩි එමීට. එමීට තවත් එමීට. අන්තිමට තව චූටයි තියෙන්නේ. සෑහෙන වෙලාවක් යනවා ඒක තව පොඩ්ඩක් අඩු වෙන්නේ. ඊටත් වඩා වෙලා යනවා ඊට ගන්න අඩු වෙන්නේ. ෆීල් වෙන්න ඕනේ. තේරුණාද කියප එක? Right? I like that way, right? When the concentration of the amount high rapidly decreasing, but with amount, when amount decreasing, rate also decrease. Ada ganda. With the time. Right? NA, NB. Below that, according to above diagram, it confirms that the rate of the reaction, within a bracket, consumption of A or formation of B. Or formation of B, close bracket, gradually decrease within a bracket, right? Gradient decrease, close bracket, with the time, okay? පුතේ ගෙදර ගිහින් මේවා පාඩම් කරනකොට කල්පනා කරන්න ප්‍රායෝගික වෙන විදිය රියැක්ටන්ට් එකක් තියෙනවා එයාගේ ප්‍රමාණය වැඩි කොහොමද එයා වැය වෙන්නේ ෆිගර්ස් දාලා ඕනම් බලන්න එහෙම තමයි ස්ටඩි කරන්න ඕන එතකොට තමයි ප්‍රශ්නයක් කියවදී ටක් ගාලා උත්තරේ හිතා ගන්න පුළුවන් වෙන්නේ හරි දැන් ඔය වාක්‍ය දුන්නාම ඔය වාක්‍ය ගෙදර ගිහිල්ලා පාඩම් කරන්න එපා මේක කාලෙත් එක්ක මේකේ වේගය අඩු වෙනවා එහෙම නෙමෙයි හිතලා බලන්න හරිද next රුලක් කරලා ලියන්න leave one line and write මේ චුට්ටක් ලියන්න ගිහින් නේද බ්‍රේක් එකක් ගන්නද අමාරුද ඉන්න අමාරු වුණත් එක වෙනකන් අඟු ගන්න නේ තව පාඩමට ආවෙත් නෑ ලියා ගන්නකො මේක විනාඩියක් ලියා ගන්න මේ if consider the volume of the container in which the reaction occurs in which the reaction occurs as V, capital V. And if it doesn't, if it doesn't change during the, progress of the reaction, doesn't change during the progress of the reaction, within a bracket, right? Constant V, volume constant. හරිද? volume constant කියන්නේ ටිකක් බාර කරලා තමයි ඔය ලිව්වේ. Doesn't change during the progress of the reaction. First bracket and right. Then we can define the rate of the reaction මේ බලන්න පුතේ. Earlier how you define the reaction rate? Earlier, change in amount per unit time. Okay, change in amount per unit time. Earlier we defined the rate like that way.